In this lecture we will see how to transform EER diagrams or entity relationship diagrams into relations. So we will see one by one. We have three types of entities in an entity relationship diagram: regular entities, weak entities, and associative entities. So we will see one by one how to transform these entities into relations in a logical model. So we start with the regular entities. From figure 4.9 we have a regular entity by the name customer, and it has attributes customer ID, which is an identifying attribute, and customer name, customer address, and customer postal code. So when translating or transforming a regular entity, we create a relation with the same name as the entity type, and we include all the simple attributes of that relation. We add all the simple attributes of their entity type in the relation. And we make the identifying attribute in the entity type as the primary key in the relation. For each simple entity type or regular entity type, we create a relation. We give the relation the same name as the name of the entity type, and we include all the identifying attributes and simple attributes of that entity type in the relation as the fields of the relation. As we see in figure 4.9, we have a regular entity by the name customer. It has one identifying attribute named customer ID, and two simple attributes, customer name and customer postal code. So we will create a relation by the name customer. We will create customer ID as primary key in the relation, and we will include the simple attributes customer name and customer postal code in the relation. However, for a composite attribute, we will include the components of the composite attribute as fields in a relation. So in the customer entity type, customer address is a composite attribute. It has three components: customer street, customer city, customer state. So we will add customer street, customer city, and customer state as fields or attributes of the customer relation, but we will not include customer address in the customer relation. So finally I have a customer relation with customer ID, customer name, and then components of the composite attribute, which are customer street, customer city, customer state, and at the end the last simple attribute, which is customer postal code. So this is how we map a regular entity. Now we will see how we will map a multi-valued attribute in a regular entity. Here is a relation here is an entity type by the name employee. It has four attributes. Employee ID is the identifying attribute. Then it has two simple attributes: employee name and an employee address, and one multi-valued attribute by the name skill, because one employee can have more than one skills. So we will create two relations. One relation which will include all simple and composite attributes of the entity type, and another relation in which we will include the multi-valued attribute. So we have created two relations, one by the name employee. Employee ID is a primary key in this relation, and the two simple attributes are included in the employee relation. These are employee name and employee address. However, for the skill attribute, which is a multi-valued attribute, we will create a separate relation. We will name it something that is meaningful and similar to the multi-valued attribute. So we named the second relation employee skill, and we will include the multi-valued attribute which is skill in this relation as an attribute. And now we will link these two relations by copying the primary key of our main of our regular entity, or which is employee ID, as a foreign key in the related relation. So here this employee ID is a foreign key, and in the employee relation it is a primary key. Moreover, in the related relations that is created for each multi-valued attribute, we will create employee ID and the multi-valued attribute as a composite key of this relation. So this is how we model a multi-valued attribute. In short, we will create one relation for each multi-valued attribute. We will copy the primary key of our regular entity as foreign key in the multi-valued relation, and we will create the foreign key and the multi-valued attribute as the composite key of the relation that is created to hold the multi-valued attributes. Now we will see how to map weak entities. As we know that a weak entity is an entity that depends on a strong entity. It means it can only exist if the strong entity exists. Here is an example. A dependent is a weak entity of employee. It means that if we have this employee entity in our diagram, only then this dependent entity type will exist. If we remove this entity type from the diagram, this will be removed automatically. Now to transform this weak entity relation in our ER diagram into a relational diagram, we will create two relations, one for the regular entity type and the other one for the weak entity type. So we have two relations by the name employee and dependent. We will model the regular entity type in the same way we have just seen, but for the weak entity type we will model the weak entity type again in the same way as we model the regular entity type. However, we will figure out the partial identifier key or partial identifier in the weak entity, and we will make it a composite key. Now in this relation, in the dependent relation, the partial identifier is first name, a combination of first name, middle initial and last name. So we will make these three. We will try to make these three as a composite attribute. We will model the weak entity type in the same way as we model the regular entity type. So we have a relation by the name dependent, and this relation has all the attributes of dependent entity type. So we have now dependent name is a composite attribute, so we will write the components of this composite attribute, which are first name, middle initial and last name. So we have these three attributes: first name, middle initial, last name, then date of birth and then gender. Now to link these two relations, we will write the primary key of our parent relation as foreign key in the weak relation, and we will make this foreign key along with the partial identifier of the weak relation as composite key. So in the dependent relation, which is a weak relation, the composite key contain these four attributes: first name, middle initial, last name, and employee ID. The first three attributes are partial identifier. It means they partially identify a dependent. Why we call it a partial attribute? Because there is a probability that all these three can be same. So they are not. They will. There is a probability that this combination can be repeated or is repeated, and hence it may or may not uniquely identify a dependent. That is why it is called a partial identifier. So we make a composite key by adding the partial identifier of the weak entity and the foreign key of our parent entity, or the entity on which the weak entity depends. Okay, to remove the complexity of this composite key of weak entity, practically we add a surrogate primary key. A surrogate primary key is the one that we add ourselves to the weak entity. It can be an auto number field or a numeric field, or a field that contains a unique number to uniquely identify a weak entity record. So in this example, they have taken dependent number as a surrogate primary key. Now why we take a surrogate primary key, or when should we add a surrogate why we call it a surrogate primary key? We call it a surrogate primary key because the attribute that we make a surrogate primary key is not actually part of the attributes of weak entity. It does not exist naturally in the weak entity. We add it ourselves just to create a numeric or auto number primary key, and we add it to increase the efficiency of our database processing. So here are the reasons for which we add a surrogate primary key. The first one is there is a composite primary key, as is the case we have just seen in this example, that we have a composite primary key, and the composite primary key contains 4 fields. You should keep in mind that the more fields we have in the composite primary key, the more time it will take to process it. So to simplify this processing time of the database, or to improve the efficiency, whenever we have a composite primary key in the weak entity relation, we add a surrogate primary key. Second reason for which we add a surrogate primary key is that the natural primary key is inefficient. Okay, it means that, let's say if we have an attribute in our weak entity that qualifies to be a primary key, but let's say its size is quite long, or it contains, or it is a textual field, so it will take more time to process. So to make it more efficient, we will add a surrogate primary key. The third reason to add a surrogate primary key is the natural primary key is recycled. Recycled means that our natural primary key, the values of our natural primary key repeat after some time. For example, if we have a bank challan number as a primary key, we know that it is a 4-digit number. It starts from 000 and it goes up to 999, and after that it restarts from 000. So it means, let's say if there is a case like this, and we have a bank challan number as a primary key in our weak entity type. Now that primary key will be recycled after a certain series of numbers. so it means it will not remain unique. So in that case we will add a surrogate primary key. So these are the three reasons in which we add a surrogate primary key in our weak entity relation. So now we will see how to map the binary relationships. We know that binary relationships are those relationships that contain two entity types. So the relationship between there can be one-to-one relationship between two entity types, one-to-many relationship between two entity types, and a many-to-many relationship between two entity types. So we will see how to map these three types of relation between two entity types. First one is map binary one-to-many relation. Let's see it through an example. Here is an ER diagram. In figure 4.12 we have two relations, customer and order, and the relationship between them is one to many. It means one customer can place more than one order, and a customer can may not place an order, because here is an option here. So its mapping is quite simple. We will map these two entities as we map a regular entity. So we will map customer as a regular entity, we will map order as a regular entity, and then we will add the customer ID as a foreign key in the order field, or we will copy the primary key of the entity type which is at one side of the relation to the as foreign key to the entity type which is at the many side of the relation. Again I will repeat, we will copy primary key of the entity type which is at one side of the relation as foreign key to the entity type which is at many side of the relation. So here we have mapped the customer relation. Customer, it has customer ID is the primary key here, then these three simple attributes. So this is the customer relation, and this is the order relation which has order ID as primary key, then order date. And to link these two relations, we have added customer ID as foreign key in the order relation. So this customer ID as foreign key will create a one-to-many relationship between customer and order relations. So this is how we map a one-to-many binary relationship. Okay, now we will see how to map a many-to-many binary relationship. Here is an example of an ER diagram in which we have two entity types, employee and course, and the relationship between them is many to many. An employee can register for may or may not register for 0 or more courses, and each course can be registered by 0 or more employees. So hence the relationship between employee and course is many to many, and the attribute of that relationship is date completed. Obviously when an employee registers a course, we want to record when the course when did he completed the course. And this is just like if we replace it with a student and course, each student registers 0 or more courses, and each course is registered by 0 or more students. So actually your registration record and the attributes of this many to many relationship in case of student and course is midterm marks, terminal marks, and it can be date registered. So in this case, first of all, we will transform these two entity types as relations in our diagram. So we will have one relation for employee entity type, another relation for course entity type, and then we will create a third relation that will and we will include the primary keys of these two entity types as foreign key in the third relation. So the third relation is named certificate, and the primary key of employee relation, which is employee ID, and course relation, which is course ID, are added in the third relation, plus the attributes of this relationship, which is date completed. And the primary key of this third relation, which is also called associative entity or gerund relationship, will be composite key of these two foreign keys, a composite key that will be made up of these two foreign keys. So this is how we map a many-to-many binary relationship. In short, we will model a two relationship just like we model a regular entity. We will add a third relation which will include the attributes of this relationship, which is in this case date completed, and we will add the primary keys of two related entity types as foreign key in the third relation, and we will make these two foreign keys as the composite key of the third relation. So this is how we model a many-to-many binary relationship. Okay, here we will see how we will map a one-to-one binary relationship. So this is the last one of the binary relationship. We have two entity types, nurse and care center. And the attribute of the relation is date assigned. Now this ER diagram shows that a nurse may be assigned, may be given charge of a care center, or may not be given a charge of a care center. So it means a nurse can be given charge of only one care center, or she may not be given charge of any care center. So the relationship between nurse and care center is 1-to-1, and the attribute of relation is date assigned. It means when the nurse was assigned charge of the date when the nurse was assigned charge of a care center. So we will model the two entity types, which are nurse and care center, just like we enter a regular entity type. So we have two relations, nurse and care center. Nurse ID is the primary key here, and these two simple attributes are attributes of this relation. Now in case of care center, center ID and central location are the attributes of this relation, where center ID is a primary key. However, this nurse ID will be a foreign key here, and this attribute, which is the attribute of this relation, this one-to-one relation, will be an attribute of this this second relation, which is on the optional side. This is important. This attribute, which is an attribute of this relationship, will be added to the relation which is on the optional side. So this relation is on the optional side, and this relation is on the mandatory side, because we have this line here and a circle here. Circle means optional, and this line here means mandatory. So we will add this attribute, which is the attribute of this relationship, to the relation which is on the optional side. So date assigned is here, and we will add the primary key of the relation which is on the mandatory side as foreign key to the relation which is on the optional side. So because case center is on the optional side, we will add nurse id, which is primary key of the nurse relation, to the care center relation. And one more thing, you can see that it is the name of this primary key is nurse id, but here it is written as nurse in charge. We can change the name of the foreign key. Their data type should be same. If nurse id is a numeric attribute, or let's say if it is a integer attribute with 5 digits integer, it should also be an integer attribute with 5 digits integer, but we can change its name. So here, instead of writing nurse id, it has written nurse in charge, but still it is a foreign key of nurse id, and this line is showing that it's a foreign key of nurse id. And this is how you present a foreign key in a logical diagram. The arrow represents the primary key to which this key points to or refers to. So it means that nurse in charge is a foreign key, and it refers to nurse id in the nurse relation, and nurse id is a primary key of the nurse relation. Anyway, this is how we model a one-to-one binary relationship.